You know the feeling? You're just driving along, minding your own business, and then, bam! That little amber light pops up on your dashboard. The check engine light. And for a second, your heart just sinks, right? It's a moment of pure universal panic.
But here's the thought. What if that light isn't just a problem? What if it's actually a message? A kind of distress call, sent from deep inside your vehicle in a language we don't always understand. So today, we're not just looking at a warning light. No, we're launching a full-blown investigation. And every good investigation needs a starting point, a central clue. For us, it's a specific, kind of puzzling code, P0001. This right here? This is our first piece of evidence in this whole automotive mystery. All right, so let's get into it. Before we can even think about solving this case, we have to learn the language. What is this distress call actually trying to tell us? It's time to decode it.
Okay, the official definition is Fuel Quantity Regulator Control Circuit Open. Whoa, that is a mouthful. But the key phrase here, the part you really need to focus on, is circuit open. The best way to think about it is like a dropped phone call. Two really important parts of your engine were talking to each other, and the line just went dead. There's a communication breakdown somewhere in the fuel delivery system.
Now, to figure out what that breakdown means, we gotta meet the key players in this story. Let's imagine it like a central command center, with its agents out in the field, all working together to manage your engine's fuel supply.
So first up, we have the Powertrain Control Module, or PCM for short. This is the brain of the whole operation. It's mission control. This is your car's main computer, and its job is to send out all the important orders. We're talking a 12-volt electrical signal that manages exactly how much fuel the engine gets at any given moment.
And who's on the other end, receiving those orders from the brain? That would be our first field agent, the Fuel Quantity Solenoid, the FQS. A good way to think of this guy is as the fuel gatekeeper. It's positioned right at the entrance to the high-pressure fuel pump, and its whole job is to listen to the brain and meter out the precise amount of fuel that gets into the system. And then we have our second agent, the Fuel Pressure Regulator, or FPR. This is the pressure controller. Its job is all about maintaining stability, keeping things from getting out of hand. If the fuel pressure ever gets too high, the FPR just opens a valve and lets the extra fuel escape safely back to the tank. It's basically the system's safety valve. So let's just quickly compare our two agents here. You've got the FQS on the front lines at the pump's inlet, controlling how much fuel enters the system. Then you've got the FPR on the back end, managing the pressure by releasing fuel when needed. They have totally different jobs, but they're both absolutely critical for the whole thing to run smoothly.
Okay, so if code P001 means there's a dropped call, a communication breakdown in this system, where did it happen? Who or what is responsible? Well, it's time to line up our four main suspects.
Our investigation is going to follow a pretty logical path. First, we look at the driver circuit. Is the command from the brain even making it to the solenoid in the first place? Second, the return circuit. Is that communication loop actually complete, or is there a break in the line? Third, we have to investigate the solenoid itself. Maybe our gatekeeper is just worn out or damaged. And finally, you always have to consider the long shot. Could the fault lie with the brain itself, the PCM?
We've got our lineup, we know what we're looking for. Now it's time to crack this case wide open and find the right solution for each of our suspects.
And you know what? The solutions here are actually surprisingly straightforward. There aren't any crazy curveballs. For each potential cause, there's a really direct action. If a circuit's got a problem, you inspect the wiring, you find the break, you make the repair. If the solenoid itself is the problem, well, you just replace it. And in that rare case that it's the PCM, that component needs to be checked out and repaired. See? The mystery has a clear, logical resolution. So we cracked the code. P001. Mystery solved. But figuring out this one little mystery, it actually reveals a much, much bigger truth about the car you're driving every single day.
We really need to stop thinking about our cars as just being these big machines made of steel, rubber, and glass. That's just not the whole picture anymore. They are incredibly sophisticated electronic ecosystems. Your car is literally a network of communicating computers on wheels, and they're all constantly talking to each other and making adjustments.
And that brings us all the way back to that dreaded check engine light. Instead of seeing it as a source of anxiety, we can start to see it as a genuinely helpful diagnostic tool. An error code like P001 isn't some vague warning. It's a super specific clue. It's your car telling you, hey, look right here. This is where the communication broke down. It turns what used to be a frustrating guessing game into a precise diagnosis.
So the next time you see a warning light, don't just see a problem. See it as a message that's just waiting to be decoded. Which really just leaves us with one final thought to chew on. If your car is already this sophisticated computer, what's its next software update going to look like? What new conversations will it be having with itself and with us?